Hi, this is Jeff Coronado on behalf of JCSC, and this is a session in Bridging the Gap. So Bridging the Gap is a sequence of tutorials that we have for young engineers, whether you are in your maybe last year of college and you're vying for one of those few jobs that will be available as compared to the number of degrees that are granted, or you were fortunate enough to land a job in structural engineering, and maybe you're in your first year of practice, second year of practice, and it's overwhelming. Grandly, it's overwhelming. So the idea of bridging the gap is to kind of bridge that gap between the knowledge that you are supposed to have, you are kind of expected to have, as you start working. But the reality is school fell a little short, because they do the best they can, but they do fall short in what you need to know to practice. So this is to try to accelerate that learning curve for you, if you will, to get up to speed in what you're expected to know and what to do. So anyway, with that in mind, the title of this session is Splicing New Plywood to an existing lumber diaphragm. If there's any terms here that are used that you're not familiar with, feel free at the end of this tutorial session to leave comments, leave questions on anything that you need clarification on or would like clarification, and we'll see what we can do. So basically, this young engineer encountered a situation here at the office, and we're talking about detail WR1, and so if you have questions that are kind of related to this, you may want to search on our channel for WR1. You might find other tutorials that are kind of associated or closely associated with this one that might also help you. You can see the hint there. Get all you can from the tutorial. Sometimes some young engineers try to kind of like jump around and do a piecemeal, a buffet type thing, if you will, where they just go and try to grab one thing. That's not the idea here, right, guys? The idea is to try to empower you to become the best structural engineers that you can as soon as possible. So the sooner you can grasp the thinking that goes on in structural engineering, the sooner you'll be armed and equipped to be able to kind of look at these situations for yourself and be able to make the decisions as a structural engineer. So don't try not to jump around, just bear through the tutorial and try to grasp, try to assimilate the information that you're receiving. All right, with that said, here's the section that we're dealing with. And again, any terms that I use that you're not familiar with, feel free to leave notes in the discussion at the end, and we'll try to point you in the right direction. So what you see here is basically a wall roof connection made out of lumber. So here is, let me do this. So here's the wall, all right? Here is the roof framing, and here is the ceiling, okay? So this is a connection between the roof, where the ceiling, the roof rafter, the ceiling joist, and the wall, the stud wall, connect. All right. Change here. Yeah, I think I'm going to leave it at that for now. Okay. Okay, so I'm looking here. We've got existing one by sheathing, and sure enough, right here, I don't know that I'm going to be able to do this. I can't quite rotate it. But you see that? Right there is the one by sheathing. So this is an old school residence. It doesn't have wood structural panel, what we would commonly refer to as plywood. It's got one by sheathing. So basically they're 1x boards that are maybe like 1x6s, laid straight and butting up side by side. Um, so we've got 1x sheathing. Um, and there is, for some reason, we need to splice that. Now I'm using this condition here to show kind of the splice. Basically, you can see right here where it transitions from where the where the 1x sheathing terminates, and then where we're going to add right here wood structural panel, or again plywood. Could be plywood, could be oriented strand board. That's covered in another tutorial session in bridging the gap. So again, you can leave us a note and we'll try to point you to the right direction on that tutorial. But we're using this detail to illustrate the transition, but it doesn't have to be in this particular scenario, if that makes sense. What we're trying to illustrate is how we determine the capacity of the new panel as compared to the existing diaphragm. So the transition can occur anywhere. It can be right at the wall, it can be near the wall as it's shown here, it can be far from the wall. Really doesn't matter where the transition occurs. So don't be misled by that. All we're trying to cover here is that there is a transition. All right, so we've got existing 1x sheathing. We're adding wood structural panel for ease of construction. Okay, we could add these boards. However, the straight sheathing, what we call straight sheathing, and its connections aren't covered in this bridging the gap session. That is covered in another bridging the gap session. So by all means, ask if you need to know more about that, and we'll point you in the right direction. But for right now, suffice to say, it is easier to build with wood structural panel sheathing. So instead of asking that the contractor use 1x sheathing to let's say replace the area that was damaged, especially if that's a large amount of area, we're going to specify that wood structural panel sheathing be used. It's easier to handle, it's easier to connect. However, then that does generate a question about the capacity of the diaphragm, right? If you have to take into account lateral forces, whether it be wind-generated forces, seismic-induced forces, if you have to take into account lateral forces, and then you need to know what the capacity is of that diaphragm, of the existing diaphragm, so that you know the capacity that's required of the new diaphragm. So then does that mean that you need to generate the calculations for the lateral forces? Right, do you have to calculate new forces? That was kind of the question that was asked by this young engineer. Oops, I can do that right. So yes, the 1x sheathing, the diaphragm has a capacity, and that's not the purpose of this session. So we're not going to cover that here. Keep in mind, the 1x sheathing is basically an archaic material, right? We really don't use it anymore. However, the NDS in table 4.2D does show the capacity of the 1x sheathing diaphragm. So if you're a good young engineer, you're probably aware of that, right? Because you're familiar with the code. And to whatever extent you're not, suggest you get familiar with the code. So you would be aware that the NDS, and I'm sorry, in particular, it's not the NDS, it's the SDPWS, Special Design Provisions of Wind and Seismic, of the component of the NDS, does have this table. So it does have a table for 1x straight sheathing. So now that you know that, would that be the document, and in particular the table that you want to use? If you do, nobody's probably going to blame you. That would be a reasonable assumption to take those values. Okay, so if you're a young, astute engineer, you'd go to table 4.2D, and that's the value that you would use for the capacity of that diaphragm. However, here's what I'll share with you as an old timer. These diaphragms, back in the day when they were used, had a higher capacity than this. So back in the day when these diaphragms would have been used, it would have been under the understanding that it would have had a higher capacity. Therefore, prudence would dictate that we at least match with our new materials, we at least match that higher capacity. So what I would take, what we take here at JCSE is a nominal capacity of 300 pounds per lineal foot. Okay, so that's nominal. So it depends on whether you are designing ultimate strength or allowable stress. You've probably heard me say this before. In timber today, I think by and large, the standard of the industry is to still design timber using allowable stress design. Too many things are set up in timber design for allowable stress, and we're still not there to be able to use ultimate strength. So even though there are some things that we're able to calculate using ultimate strength, by and large, I don't think that's what the industry does. So I would certainly recommend that you still stick to allowable stress design, but either way, for purposes of this tutorial, just be aware that the 300 pounds per foot that I'm mentioning is nominal. You either have to take a capacity reduction factor if you're using ultimate strength. You need to take an allowable stress reduction if you're using ASD design, okay? But I would start off with a nominal capacity of 300 pounds per foot for the 1x sheathing diaphragm. Then what you need to do is provide a wood structural panel capacity that exceeds the capacity that you just calculated, that we just discussed for the 1x sheathing diaphragm. Again, taking into account a 300 PLF nominal capacity for the 1x sheathing diaphragm. So whether you use ASD or ultimate strength, you want to take the capacity of the wood structural panel for whatever nail spacing and thickness and grade of lumber you want to use, and nail spacing, and just make sure that that capacity matches the nominal capacity, a nominal capacity of 300 PLF. And that's basically it. That's how we would approach this kind of oh, I'm sorry, I guess one thing that I didn't mention is the fact that there is a seam here. But that splice is covered in another tutorial in bridging the gap, so I'm not going to get into the splice itself. But in terms of just matching capacities, the crux of it, I would say, is no, we wouldn't calculate the capacity of or recalculate the lateral load resistance of the entire structure, or the lateral load demand on the entire structure. We would kind of back into it. This is one of those where you can kind of back into it, and as long as your new capacity equals or exceeds the existing capacity, you know you're good to go. You don't have to recalculate the entire demand. All right, clear that, and I think with that we're done. Make sure. Yeah, so by all means, please give us a thumbs up if you found value in this tutorial, if it helped you. Sure would appreciate you giving us a thumbs up. If you have any comments or suggestions on how we can improve these for you as you are navigating that transition from being that student in college into making the transition into practicing structural engineering, by all means, let us know, and we'll see what we can do to help with that. If you enjoyed this tutorial, certainly suggest you subscribe to our channel, the JCSE channel, and that way you get automatic notifications as we put up new structural engineering design tutorials, okay? All right, real good, guys.